Welcome to The Explainer. Today, we're pulling back the curtain on a quiet but massive revolution that's happening deep inside the technology we use every single day. All right, let's just start with a question. Think about your car for a second, or a modern factory, even a smart building. What's really going on under the hood or behind the walls? You'd probably picture some kind of clean, hyper-efficient digital brain, right? Well, the reality is, it's a little bit different. In fact, the answer is a shocking amount of complexity. It's really this tangled web of different communication systems, a whole mess of digital languages that were never built to speak to each other. And that creates inefficiency, it adds cost, and it's a huge headache for engineers. So let's dig into this problem of our tangled digital world. Engineers have a great way of describing it. They call it a system of isolated network islands. So take a modern car, for instance. You don't just have one network, you've got tons of them. The engine control, the powertrain, that's on one network. The chassis and body controls, they're on another. And your infotainment system, the telematics, they are all their own separate islands, and each one is speaking its own unique protocol, things like CAN or UART, and a bunch of others.
So how in the world do you get these islands to talk to each other? Well, you have to use these things called gateways. And you can just think of them as these really expensive, slow, and clunky translators. They have to constantly take one protocol and convert it into another. And that adds cost, it adds weight, and it creates delays. It's a massive bottleneck, especially when you compare it to a system that uses simple switches, which just route traffic between devices that are all speaking the same language.
But what if you could just get rid of the islands and get rid of the translators altogether? What if every single component, from the biggest computer down to the tiniest little sensor, could all speak one universal language? Well, that brings us to the breakthrough solution. It's called Single Pair Ethernet, or SPE, and the genius of it is all in its simplicity. It takes Ethernet, the same powerful universal networking language that runs the entire internet and all of our offices, and it makes it work over a simple, lightweight, single twisted pair of wires. Just two wires. Now, the specific version that's really making all this possible at the device level is called 10BASE-T1S. And honestly, it's the hero of our story today. It's a standard that's designed specifically for connecting lots of devices over shorter distances using what's called a multi-drop bus, which is basically like a digital party line where a bunch of devices can all share the same wire. So this one standard lets you connect 8 or even way more devices on a 10 megabit per second shared connection over a single cable stretching up to 25 meters. And thanks to this really clever feature called physical layer collision avoidance, they can all talk on that party line at the same time without their messages crashing into each other. And the result? It's huge. We're talking drastically lower cost, way less weight, and much, much simpler wiring. This technology makes a whole new way of designing complex systems possible. We're seeing this fundamental shift in architecture, moving away from the old domain model and into a new zonal one. So the old way, that's the domain architecture you see on the left. That's what we have now. It's organized by function. You have dozens of these electronic control units, or ECUs, each with its own job, and they're all tangled together with those complex wiring harnesses and gateways. But the new zonal architecture, on the right, that's the revolution. It organizes the system by physical location. You have a powerful central computer that connects to these simpler zonal controllers, and each controller just manages all the sensors and actuators in its physical zone, like, say, the car door or the front bumper. The benefits here are just transformative. First off, the wiring becomes radically simpler and lighter. Then you get to eliminate all the gateways and reduce the number of expensive controllers. That, of course, drives down the cost of everything, from the copper wire to the software development. And maybe most importantly, it creates a flexible, software-defined system where you can add new features with a simple update, not a complicated hardware change. And look, this isn't some far-off futuristic concept. This great simplification is happening right now across a ton of different industries. Let's take a look at where SPE is already making a huge mark. In the automotive world, it's a complete game changer. I mean, just think about a car door for a second. The window controls, the mirror motors, the speakers, the locks, they can all be connected on one simple 2-wire 10BASE-T1S cable. And the same thing goes for all the sensors in a bumper, the controls in a seat, or even the incredibly complex network inside an EV's battery pack. In factories, SPE is connecting the thousands of tiny sensors and actuators that are really the eyes and hands of modern automation. It's streamlining communication on assembly lines, and it's replacing all this expensive proprietary wiring inside control cabinets, which makes manufacturing so much more flexible and data-rich.
And it doesn't stop there. Smart buildings are using it for lighting, for HVAC, for elevator controls. Data centers are using it for monitoring their internal fans and temperature sensors. It's even being adopted for the next generation of megawatt-scale EV chargers, where its toughness is absolutely critical in those high-power environments.
Okay, so let's just step back for a moment and really appreciate the big picture here. This isn't just about replacing one type of wire with another. This is about creating a single, unified, and scalable communication backbone for our entire technological world.
This quote, it just nails it. This is the end game. Ethernet becomes the universal thread that connects everything, from the most powerful cloud servers all the way down to the simplest sensor at the edge of the network. That sensor on a factory robot or in your car's bumper, it creates a seamless data highway. And that unlocks levels of connectivity and intelligence we just haven't seen before.
By tearing down the walls between all those old network islands, we're not just making our machines simpler, we are laying down a totally new foundation for innovation. And that leaves us with a final, really exciting thought. When every single component in our world, big and small, can speak the same universal language, what incredible new possibilities will we unlock? What are we going to build next?